Hello and welcome to Weka. Thanks for clicking. My name is Michael Green, and in today's video we will be talking about object storage, how to connect to it, how to use it, what use cases it enables. So without further ado, let's jump straight into it. So let me show you what I have here. I have here two clusters. Let me bring them right in. And you know what, let me get myself out of the way. So two clusters. One is going to play the role of a production system, and the other one is going to play the role of a DR system. And they look the same, I know, but these are actually two different clusters hosted on AWS. And they are also in different availability zones. So what I'm going to do first is that I'm going to connect an object storage to the first one. So I'll click here on object storage, and oops, I already have one. Let's pretend that it has never been here. Let me delete it and let me connect to it again, because I want to show you how easy it is to connect a bucket to Weka. So it's going to be a C Michael S3 demo. That's the name of my bucket. And now I need to grab here this access key. Here it is, and then I need to grab my very secret key. So we click validate, and it tells you configuration verified successfully. So we are able to communicate, and the bucket is responding correctly. So we'll click configure, and that's it. We are done. Our bucket has been just added. So where do we go from here? Let me go to file systems. I have here a couple of file systems. This one, I used this for other project, and I have this production file system, ProdFS, that I'm going to use for our little testing experiment right here. So I'm going to check on my Weka client. And by the way, I have here my terminal is split into two. The left side is my production environment, and the right side is my DR environment. Right, so I'm going to hide the DR side for now. And let's see, df-h-t Weka-FS. What do I have? I have here two file systems. So that default file system and the production. It's exactly 2 terabyte, right? So let me check how I can change the size of it. So let me make it maybe 5 terabyte. So I'll change this to 5 terabyte. Click configure, and going back to terminal, as you can see, it's now 5 terabyte, up from 2 terabyte as before. What I want to take a note here is that I have a single field for the capacity, right? That's the only value I can change. This file system is now entirely in NVMe. So, but because I have object storage connected, what I can do, I can make this file system tiered. So I just click attached object store, and I will choose my bucket, and I'll click attach. All right, so with this, I can now do a couple of things. First of all, I can start tiering my stuff automatically. That's the first thing we can do. The second thing we can do is that we can do what is called snap to object. So let's talk about the tiering policy first. Right, so the tiering policy, and maybe I will bring a slide here, and let's talk about that a little bit. So the tiering policy that Weka has is based on the age characteristics of data. The idea here is that as the data ages, it becomes probably less frequently accessed, less often accessed. So it makes sense to migrate older data to slower storage. So we will tier this to object. Now the tiering policy is applied to file system through something that is called file system groups. Right, so every file system in Weka must belong to a group, and you can move them freely between different groups. But the policy, the takeaway here is that the policy is not a property of the file system. It's a property of the group where a file system belongs. In other words, a file system inherits the tiering policy from the group. So how do we configure tiering policy? Very simple. 2 parameters that you need to know: tiering queue and drive retention period. So what is tiering queue? Tiering queue is the length of time from the moment we created our data and until it can be tiered or uploaded, right? Pay attention, can be tiered, not will be tiered, right? It's basically a hint to Weka that from this after that long of a after that long time, you can actually start uploading the data to the object store. And then we have, once it's uploaded, it stays on the SSD as read-only cache. And then there is drive retention. So what drive retention? Drive retention is the length of time from the moment the data was uploaded and until it can be released from the SSD completely. In other words, the time from the moment we uploaded and until we don't need that data for the caching purposes anymore. It's been so long since we touched it last time, we're probably not going to touch it again in the near-term future. So another way to think about these two parameters is this. Tiering queue should be the amount of time until the file content stabilizes. You see, once you write the file, it's not always written in its final form, right? Sometimes users continue working with it. They maybe apply changes to it. They will change some ranges, override them. So we want to make sure that that data doesn't change a lot when we will be moving it over to the object storage. So that's the length of time. We are not going to touch the data from tiering perspective. We are not going to upload it. And then we have the drive retention. And that field, that value indicates the time when file no longer needed in the SSD read cache, right? These two parameters. So with that, let's go back and have a look. So our tiering policy on this file system is configured as 2 minutes for tiering queue and drive retention is 6 minutes. Why 2 and 6? That's because our best practices recommend to have a ratio between these two values of 1 to 3. So if it's 1 minute here, 3 minutes here, 1 day or 2 days, let's say 2 days here, then it should be 6 days on the drive retention. And so with that, let's head over to the terminal again. And what we're going to do here, I'm going to use a tool called Goder to create some files. So let's run that. Now this tool it's an open source tool that available from GitHub. Was written by one of our developers. It's really good at creating lots of files fast. So a couple of parameters that you have to supply, and I have constructed here a command that basically sends the Goder command to the two clients that I have, and they just create a whole bunch of files, like 12,000 files per client. And the total size here that I have is, at the moment, is 6 terabyte. So if I check here, df-h-t Weka-FS, you will see that minus lowercase t, you will see that I have here 6 gigabyte of data written in a few seconds. All right, so what will happen from now? If I do nothing, the system will start tiering the data, uploading that data to the object storage. After how long? After at least 2 minutes. At least 2 minutes, maybe even longer, maybe 4 minutes, maybe 6 minutes, right? So you can't say for sure when this will happen because we specify the minimal amount of time, not the absolute amount of time until the data can be uploaded, right? So close. So what we could do, we can actually see if something is happening. If the data upload is happening, I will go over to statistics and I can plot here some stats pertaining to object storage. So I can do here, for example, a click on object, and I can use this filter to select. So I can say, for example, OBS write. I can plot OBS write, and I can plot also OBS read if I want to. And then I basically will just sit and wait here for a bit of time, and also this side. So let's plot the statistics. The resolution here is about is 1 data point per minute. So it can take anywhere maybe 2 to 4 minutes until we see the first data point pertaining to the upload of the data plotted, right? But we will not wait. We will come back to that later. In the meantime, what I would like us to do is that I would like us to go ahead and resize this file system. Right. So this file system at the moment has only has 5 terabyte on the NVMe and 5 terabyte on the object. Right. So I want to make my total capacity larger at the expense of the object. So I'm going to say here 50 terabyte. That's what I want to have. Configure. Once I do that, if I go back to the terminal and I do my df command again, you will see that the file system is now 50 terabyte, just like that. And think about it. The users see now 50 terabyte. They don't really know where their data resides. They don't really know where that extra 45 terabyte is coming from. They have no clue. And this is how it's supposed to be. They just need to work. They need to focus on their work, right? They shouldn't be they should not bother themselves with knowing Weka architecture and how the data moves and all of that stuff, right? Your scientists, your researchers, your specialists, they should be working on the stuff they know and they like to do, not the IT, not the storage stuff. And a couple of things to know about this, about how this works. So all the writes will always go to the SSD, and all the metadata is always managed on the SSD. So access to the metadata is always fast. It's always fast. So for example, let's go and check our statistics if we got anything uploaded, and there we go, right? So we just had some data sent to the object storage at 100 megabyte per second. And I can list my data. Just do prod-fs, and look at that. That listing is very fast. Now this stuff is now mostly on the object storage, yet the listing is very quick. How is that? That's because the metadata is managed on the SSD. That's the reason for that. All right. So next thing I'm going to do, I'm going to take that file system, and I'm going to create a snapshot. I'll click Manage Snapshot. I'll say Create Snapshot. Okay, the snapshot step 2. And I will say Current Snapshot. I'll click Create. By the way, what you just saw here is that I can actually create a snapshot of a snapshot. We allow that. So I could say that my source is the snapshot. I could create a clone of the snapshot, essentially. It's also possible. So I have this snapshot, and I will now go to my snapshot and I will upload it to the object. This is what we call snapshot to object. It's a high-end function of Weka where what we do is that we take your data and metadata, everything, and we ship it to the object storage. And so having that snapshot in the object storage opens a whole new world of possibilities. So how do you use that? So once the snapshot is created and uploaded, you get something that is called object store locator. We also call this a manifest. So you can use this string to restore this snapshot from this object store to any Weka system, this Weka system or any other Weka system that has access to the same bucket. Right, so let's see how that works. I will go over to my DR system. I will click here on the object stores just to show you that I'm already connected to the same bucket. I did this ahead of time, ahead of the demo. So I'll now go to the file systems. I will now create a new file system. I'll click Add File System. I will call it, I don't know, prod-fs. And I will say tiering on. I will give a drive capacity. It's going to be 5 terabyte. My total capacity is going to be 50, same as before. And I'll say from uploaded snapshot, and I'll give the object store locator. And I will click Create. And just like that, we just restored that file system from the snapshot. Look at that. You remember we had here 5, where was it? Here, 591 gigabyte. Same here, same exact size. Right, so let me go to my terminal, and I will now switch to my DR system. And I will do here, this client is a totally different client. It's connected to my DR cluster. So it has no knowledge of the first Weka cluster. So we'll do here Weka-FS, and I have here this file system already available to me. So I can now mount it. I'll say sudo mount -t Weka-FS, and I will say here prod fs 2mnt. Let's call this restore. It's a restored file system after all. df -h -t Weka-FS. Look at that. It's the same size, right? The same size that I gave and the same amount of data in it. So let me just list it. And you will see how fast this is. It is fast because the metadata is already on the flash, right? We restore the metadata very quickly. And even though like 99% of this data is still on the object, the metadata is with me. It's on the flash. So I can do any operations involving metadata, such as listing, deletions, what have you, searches, right? All of that is as fast as if it was local to me. So this is how you can restore file system from a snapshot on the object. So this is what we call snapshot to object. It's a high-end feature unique to Weka that opens a whole new slew of possibilities, right? So let's talk about those possibilities. What can we do about that, right? Just to give you some ideas, let's go to the next slide, right? Snapshot to object. So again, the scenario here is that you have your Weka cluster, you have your file system, you take a snapshot, you connect your Weka cluster to an object, and you just take a snapshot, and then you ship this snapshot data and metadata, everything in its entirety onto the S3. Then let's say something happens to your cluster, and you spin up a new Weka cluster, maybe even in the same data center or the same availability zone, and then you can just restore it like this. You get your file system. Another possibility is to do the same in a different data center or a different availability zone, like we had here, disaster recovery site, right? So how can this work? Let's think about that. There are a couple of possibilities here, actually. So, for example, if we are speaking about Amazon, so S3 is a cross availability zone service. So that same bucket will be available to me anywhere in any availability zone. So I don't even have to replicate anything. But if it's a real data center, not a virtual, not a hosted one like Amazon, then you could have another object store hosted in your DR site, and you can replicate between them. There are some high-end object stores, products, platforms that can replicate. So you would ship that snapshot over to your other site, to the object store located in there, and then you can spin up Weka cluster in that site and you can restore. Right? Okay, so let's talk about the use cases, right? We divide all the use cases into three major categories: generic use cases, either on-prem or cloud-only use cases, and hybrid cloud use cases. So generic use case is external backup, right? The external backup is enabled by the fact that, first of all, when you send data to object store, it's a different media, right? It's not the same media as Weka, it's not NVMe, and that's a very important characteristic of the backup, right? Some people think they take a snapshot and they have backup. Not true. True backup should reside on a different media than your file system, than your working set. Should be different set of media. So external backup is on the different media, and second of all, it's due to the fact that our snapshots are incremental. In other words, your snapshot is going to be relative to the first one, and your third one is going to be relative to the second one, right? So using that, you can implement an incremental forever policy. What you can do is that you can take snapshots and then another snapshot. You upload the first one, you upload the second one, you take a third snapshot, you upload that one too. You keep those manifests, you preserve those locators, right? Maybe in a database or in your enterprise orchestration software somewhere. And you can keep going like that essentially indefinitely, right? Indefinitely. With the moment you need it, you just go, you pull the correct manifest, and you just restore that snapshot. That's huge savings right there in terms of capacity, just because our snapshots are so efficient and they're incremental. Then archiving of cold data. Just imagine that you have a set of data that you need to preserve for, let's say, maybe regulatory reasons. So what do? You have that data in the file system, you take a snapshot, you upload that snapshot, you delete the file system. You safeguard your manifest, because without it, you cannot recover that snapshot. So you have that manifest, and that's it. And that data is now on the object store. It's not taking that valuable space on the NVMe, right? Data that you don't work with anymore. Then there is a scenario of asynchronous replication to know the geography enabled by the object stores. Essentially, you push your snapshots, object stores replicate right there, right? And then you essentially restore. You can continuously restore that file system on the cluster. So that's the third use case within generic use cases. Now, cloud-only use cases is AWS post restart. It's actually somewhat similar to the archiving. You have your Weka cluster connected to S3. You take snapshot, you upload it, right? Maybe you're done working for today or for this week. You destroy your Weka cluster, leaving that snapshot to object on Amazon S3, right? You walk away, you come back, maybe in a month, you need to work on that data again. What do? You spin up your cluster, and you just use your object store locator to restore that snapshot back, and that's your restart, right? So you had pause, you had restart. In the meantime, you didn't have to pay for the EC2 instances. Only you had to pay a little bit for the S3 object, which is not very expensive. AWS protection against single AZ failure. Again, you being a prudent and foreseeing user, you were taking those snapshots, you were uploading them from time to time to S3, and when disaster occurred, and it can happen, even with Amazon, you then just restore, you spin up a new Weka cluster and you restore from that snapshot. You can use that same mechanism to migrate, right? Again, snapshot is uploaded, you migrate to a different region, just simply because on AWS S3 is a cross-region service. And then there is the use case of cloud bursting. In cloud bursting, what happens is that you work mainly on-prem, but sometimes you have more work to do than your local resources allow you. So what do? You take a snapshot, you upload it, you spin up Weka in Amazon, you recover that data, you restore the data from the snapshot to that new cluster on Amazon, you work with it, you do your processing, you're done, you take snapshot, you upload it again, and then you download it back on-prem, you destroy your Weka cluster in AWS, and you're done. So this is a case of cloud bursting, right? So these are like some use cases that immediately come to mind. You can maybe come with more. But that's what it allows you to do. Lots and lots of flexibility with this feature. Lots of things that you can do. And let's go back and check our statistics. And that will be the last thing we're going to do today. So we need to go back to this cluster actually and click here to statistics. And yeah, it was actually very quick. There was not a lot of data. It was all uploaded very quickly. So this is how you can check. This is how we can use Weka statistics just to see what's going on. You know, how much data is uploaded, downloaded, and so on and so forth. And that's all I have for us today. So thanks a lot for sticking around and your attention. Your attention is precious to us. We don't take it for granted. Please join our learning portal, right? We have lots and lots of trainings like that on our learning portal. We have trainings on all kind of things, anything Weka, AI related. And we also have an additional, if you're interested in object, how about the inner workings of object. So you can always go to the learning portal. We have an hour-long training there that goes in depth in how things work behind the scenes. Very cool stuff. So thanks again, and until the next time, bye-bye.